expertise and even being one of the discoverers of part of what we know about the sun is amazing. But help us now to see what this teaches us about creation.
Sure. I think, first of all, the existence of the sun is a confirmation of creation. The sun is a ball of gas. Now, hydrogen and helium, the gases the sun's made of, they're very abundant in space. But here's the problem. If you want to say there's no God and the sun just kind of formed, gas doesn't want to collapse in on itself. I mean, the air in this room doesn't just go off into that corner. It tends to expand. Yeah. Right, that's the natural property of gas. And in space, it'll tend to do that too. In space, there's no container. It just expands indefinitely. Theoretically, if you could get it extremely cold, you could get it to collapse in on itself. But it doesn't exist that way in space. No. In every region we've seen in space, gas is expanding. It really doesn't want to collapse in on itself. And even if you could get it to start collapsing in on itself, there would be other problems that would prevent a star from forming. For one thing, gas has a little bit of motion to it, even a little bit of rotational motion. And so when you collapse that in, just like a skater, when she spins around and she pulls her arms in, she speeds up, right? The same thing would happen with gas. As it would collapse in, it would tend to speed up, and then the angular motion would tend to prevent any further collapse. It would tend to repel. It's kind of hard to pull something in when you're spinning like that. Yeah, if you ever played with weights and tried to pull them in when you're spinning, you'll speed up, but it's hard. And then a third characteristic that would tend to prevent a star from forming by collapsing gas is the magnetic field, because magnetic fields will thread through the gas that's in space, and when you compress that, it's like pushing a north magnet to a north pole to a north pole. It wants to repel, you see. Magnetic fields don't naturally condense like that, and so the fact that we have a sun seems to be an indication that it was a supernaturally created object. The universe was created, and then God placed these objects in it by His power.
Right.
We also have the fact that the sun appears to be young in the sense that it does things that would indicate that our solar system is young. One example of that is the sun tends to destroy comets. Comets are made up of ice and dirt. They tend to have elliptical orbits, and they come in close to the sun and they get whiplashed back out. Now, when the ice is far away from the sun, it's not a problem. It remains frozen. But when these comets come close to the sun, the solar heat, it vaporizes that icy material, and that's what forms a comet's tail. The comet's tail is material being blasted away from the nucleus of the comet. Every time you see a comet, it's getting smaller. I used the SOHO spacecraft to look at the sun, and it's got an instrument that actually blocks the sun and looks at the region surrounding it. So you can see the corona, and it's great at spotting comets, because when comets get close to the sun, we have trouble seeing them on Earth because the sun's out, when they're out, and the glare gets in the way. But SOHO is designed for that. And so comets get very bright, and I've seen comets that have gone behind the sun, and then that's it. And the sun does other things too, sweeping up the dust. There's dust in our solar system, basically, and the solar radiation tends to push on that dust. And depending on the characteristics, it'll either push it into the sun, ironically, or it'll push it away, the Poynting-Robertson effect. And so the fact that we still have a lot of this dust in our solar system really confirms that the solar system hasn't been here that long. It certainly hasn't been here billions of years. We also have something called the faint young sun paradox, and this is something that I think is very interesting. You see, in the standard view of how stars age with time, stars are supposed to become a bit brighter with time as more of the hydrogen is converted to helium in the core. Things collapse in, and it actually tends to make the star brighter. At least that's what we think should happen with time. Which means if the sun really were billions of years old, then 3.8 billion years ago, the sun should have been about 30% fainter than it is today. 30%, which means the Earth's getting 30%. Yeah, the Earth's getting 30% less energy. And so that's a problem, because that's supposed to be the time when, according to the seculars, life is supposed to be evolving on Earth. But it's hard to imagine the Earth could be anything other than an icicle if it were only getting 30% the amount of radiation from the sun that it's getting today. I mean, that's a huge difference. Yeah. And from everything we can tell from the fossil record, if anything, the Earth, we think probably before the flood, might have been a little warmer than it is today. It might have been kind of a subtropical world in many places. Even places like Antarctica, there's evidence of tropical sorts of plants there that don't grow there now, but that we find fossils of them. And so this is actually a problem in the secular view, the faint young sun paradox.